Okay, so what we're going to work on today is finding the turning point and then using the turning point in applications of problems here. All right, so it has try this and put me on pause and then come back. Okay, so hope you did the try this, and the first one says, what is the general form of a quadratic? So the general form for a quadratic is f of x is equal to ax squared plus bx plus c. And the axis of symmetry, remember, is that invisible line that goes right through the parabola. Remember that formula is x is equal to negative b over 2a. Okay, the vertex form for a quadratic is f of x is equal to a times x minus h squared plus k. And remember, the axis of symmetry is x is equal to h. Remember, you have to change the sign. All right, so now let's talk about the turning point. The turning point on the parabola is the max or the min. So it's either the max or the min. So if your a is less than 0, that means it opens which way? It opens down like this. So that means it has a max. If your a is greater than 0, that means it opens up and it has a min. All right, so now let's just take a quick look at a graph of a parabola. So let's say I have this parabola. Okay, it opens down, so that means a is less than 0. Right, so I have my x, I have my y, which is f of x. Okay, and this here is my turning point. Okay, now the turning point, what goes right through the turning point is the axis of symmetry. Okay, so remember that. So when you have general form, so this is x equals, whatever number, okay? So then how do I get my turning point? If I have my x value of this point, that's my axis of symmetry, how do I get my y value? Well, then I have to do f of x to get my y value. So it's really f of the turning point. All right, so when you have general form, which is f of x is equal to ax squared plus bx plus c, right? You do the axis of symmetry, which is x is equal to negative b over 2a, right? You get that point down here. And then your turning point, or your max, right? Your x value is negative b over 2a, and your y value, well, after you get your x value, you have to plug it in. So it's f of negative b over 2a to get your y value. For general form, it's f of x is equal to a times x minus h squared plus k. Now, we know hk, the vertex, right, is hk, and your vertex is also your turning point. So your turning point is hk. Okay, so let's just try an example algebraically, and then we'll go to the word problems. It says, find the axis of symmetry and the turning point algebraically. So we're going to start with general form. So we have f of x is equal to 2x squared minus 4x plus 3. So to find the axis of symmetry, we're going to do negative b over 2a. So that's 4 over 2 times 2, 4 over 4, which is equal to 1. So I have x is equal to 1. So in my turning point, I have my x value is 1. So now I need what's my y value going to be? So I'm going to do f of 1 to get my y value. So it's 2 times 1 squared minus 4 times 1 plus 3. So f of 1, so just plug that in your calculator, you get 1. So my turning point is 1, comma 1. And that's my, that would be my min, right? All right, so now vertex form. So we have to take f of x equals 2x squared minus 4x plus 3 and put it in vertex form. So we're going to minus 3 from both sides. We get f of x minus 3 is equal to 2x squared minus 4x. Divide everything by 2. Right, because it has to be, x squared has to have a 1 in front. So it's f of x over 2 minus 3 over 2 equals x squared minus 2. So then we're going to do half of negative 2, which is negative 1, square it, add it to both sides. We get f of x over 2 minus 3 over 2 plus 1 equals x squared minus, oh, there should be an x there, minus 2x plus 1. I'm just going to move everything up. Okay, so we factor the right side here, and this becomes x minus 1 squared equals f of x over 2, and then that becomes minus 1/2. All right, and then we're going to add 1/2 to both sides. So we get f of x over 2 equals x minus 1 squared plus 1/2. To get rid of the 2, we multiply both sides by 2. So I get f of x is equal to 2 times x minus 1 squared plus 1. So therefore, my turning point is my vertex, which is 1, 1. That would be HK. Okay, so let's flip it over and we'll work on the back. Okay, so what we're going to do to solve the word problems is we're going to use the calculator. Okay, so we need you guys to get really good on changing your window and using your calculator to find certain things. All right, so let's see what it says. A ball is hit 3 feet above the ground with an initial velocity of 100 feet per second at an angle of 45 degrees. The path of the ball is given by the function f of x equals negative 0.0032x squared plus x plus 3, where f of x is the height of the baseball in feet and x is the distance the ball is from home plate. Find the maximum height of the baseball. How far would the baseball fall from home plate? What distance from home plate will the ball be above 50 feet? So I have to find 3 things. So the first thing is I want you to draw a picture. Draw yourself a sketch. Okay, so I know the ball is being hit from 3 feet above the ground. So it's going up, and then it's coming back down. All right, and this is x. This is the distance from home plate. And this is your y value, and that's f of x, and that's your height. Okay, so let's start with the first one. The first one is find the maximum height of the baseball, which means I want to find this point right here, the maximum height, which is the turning point. Okay, so you're going to put the function into y equals and hit graph, and then when you notice, look at your graph, you can't see the whole graph, so you're going to have to change the window. So you need you to work on changing the window. So when you go in your window, you have to, it's a game, you have to kind of like play around with it. I started off by changing my max x to 100, and I realized, oh, well, that's definitely not enough. So then I went to 200, and that still wasn't enough. And then I went to 400. And when I went to 400, what I did was I changed my x min to 20, negative 20, and then I changed my scale to 20. So that I went 20, 40, 60, 80, 100. And then to see higher up on the graph, you want to change your y max. So I started off with 50, realized that was not enough, so I went to 100. And therefore I changed my y min to negative 10 because the baseball is not going to go into the ground. And then I changed the scale to 10. And then I graphed it and I saw a nice picture. So now I want to find the turning point. So you're going to, first let's write down, work on changing window to get full picture. Okay, and then what you're going to do is you're going to find the max. So you're going to find max. So you do second calc using the calculator. So you do second calc, you do the max, you do left bound, right bound, and you ask it to guess. And then the turning point comes out to be, so your max is 156.25, comma 81.125. So which means that this point right here on your x-axis is 156.25, and your height, your max, is 81.125. So let's write that down. So we have a max height at 81.125 feet. Okay, so the next part is to find how far the ball will fall from home plate. So I want to know where it's going to fall, which is over here. What is this called? This is called your zero, or one of your zeros, right? So you're going to do second calc. Number 2 is your zero, right? You do left bound, right bound. You want it to guess. And then this point comes out to be 315.47174, comma 0. And so let's write that down. Use calc to find zeros. That's where it hits the x-axis. Okay, and so it hits the ground. I'm just going to round this. So ball will fall. Ball will fall 315.5, I rounded it, feet from home plate. Okay, next part. It says, what distance from home plate will the ball be above 50 feet? So here's 50 feet, right in here someplace. Okay, I want to know for how long will it be above 50 feet. So I want to find these 2 points here. So graph this line, which is y is equal to 50, and find the points of intersection. Okay, so graph y equals 50, find the points of intersection. So you do second calc, intersect. Okay, you do, just make sure you bring the cursor closer to the point you're trying to find. Okay, and let's write that down. Use calc to find where the graph intersects y equals 50. All right, so this point right here is 250. I'm going to round it. So I have 250. Well, I'll write the whole thing out. 254.87334, comma 50. Right, because that's my y value. I know my height is 50. And then do the other point. So do second calc, intersect. Bring the cursor closer to this left point. So hit enter, 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 and you get 57.62664, comma 50. Okay, so let's write that down. So the ball will be 50 feet, will be actually above, put that right in there, 50 feet between 57, I'm going to round this, 6 and 254.9 feet from home plate. So this is an inequality because it's above 50 feet here, from here to here. So that's why it's an inequality in there. Okay, so that's it. We'll practice more in class tomorrow. Have a good night.